In this video, we will design of TV studio with width of 15 meter and length of 30 meter with upstand beam with a clear height of the hall 12 meter. In the hall, no column is allowed. The hall basic dimension is 15 meter wide, 30 meter long and 12 meter high. So let's start with the new model in the ETABS software. So after clicking file, the new model, and this in the blank space, this window will appear. After that, we will define the grid system in which we will draw our beams and column members. So I am going to define the grid system here. In the grid system, in the story data, first of all, in the grid system, I am going to modify. So here I am defining the grid spacing and the grids in the X grid data A, B. For example, it's 7.5 meter. Basically, we have to cover 30 meter. For that purpose, 15 meter and 15 meter will become the 30 meter. And for the grid Y grid data 1, I am taking the ID 1 and it is 7.5. Okay, now we can see 15 meter width and 30 meter long grid we have defined successfully. Now I am going to define the story data in which I will define the story height. So basically I will define two stories to define the bracing height. For example, each story is 6 meter and 6 meter, which will become 12 meter. Okay, so now I can see it's a 15 meter. Let's see in the plan of story 2, apply. Okay, so here we can see it's a 0 0. Here you can see the coordinates 0 0. Here is 30 meter long, and in the length, in the width wise, it's 15 meter. So in the elevation, see in any type of elevation, here is you can see z is equal to 12 meter. So we have successfully defined the grid system. Now let's define the material and the cross-sectional properties of the structural members. First of all, material property, there is already defined the rebar, which is steel material, and FC prime 24 megapascal and FC prime 28 megapascal. I will define a new material with FC prime 20 megapascal, a new material. It's a concrete material. So I will, as it is already pre-default concrete, its strength members strengths are defined. So we will define user according to our needs. FC prime 20 megapascal. So here in the design property data, I will define 20 megapascal. Okay, so here I have defined another concrete strength material, FC prime 24, 28 and 20 megapascal. Now I will define the bar, add new material, steel, basically used for steel cross section members, but for reinforcement we use rebar. So I will define the rebar of grade for 20 megapascal, grade for 20 megapascal. So here I will change for 20 megapascal. Okay, so here we have defined for 20 megapascal because there is already bus. I I showed you how to define the material of steel bars and concrete strengths. Okay, now I will go in the defining frame sections. In the frame section, there is two already: automatic beam selection, beam column selection. We'll try to this here. Here is the beam 225. 225 I will delete and define again. Add new property from concrete, a rectangular cross section. Here I will define beam 225 by 225, and here I will define 225 by 225. And what's the material of this beam? I will select from here 24, 28 or 20 megapascal. I will select 20 megapascal, and I will define whether it is a beam member or a column member. So I will select from the reinforcement tab. It's a design type column, not it's a beam 225 by 225. Here I can select the grade of the steel, whichever I want. So definitely I will select grade for 20 megapascal steel for SI system. Okay. So here is define. I have defined another beam. So I will delete again a column and define again to show how to define a column in ETABS. Add new property, concrete column, concrete rectangular cross section. Here is COL for column rotation 300 by 300. So I will select the material property again, rebar for 20 megapascal, and define the cross section by defining its dimensions 300 by 300. I will select material, it's a column, so definitely concrete strength of FC prime 28 megapascal, and I will go in the modify column 420 by 420. I will select 3 in the X direction, 3 in the Y direction. Maybe I will select a little lower. These are trial reinforcements in the longitudinal direction, in the confinement direction. Basically, we will reinforcement to be designed. We will check at the end the reinforcement designed by the software. Okay. Here is defined. I have defined the column 300 by 300. Here I will also define for all the beams auto beam selection, and for columns auto column selection. Software select from all the lists, like I will show auto select list, auto select beam. In the auto select beam concrete, I will select all the beam under the heading of auto select beam here. So first, for definitely I will start the trial from beam 225. Software automatically perform trials first of all in 225 millimeter beam, then 300 by 300, 300 by 450. Software automatically optimize which beam member is suitable at any location. Similarly, we will define auto column, auto selection column, auto selection column. Okay, selecting the material property, it's concrete. So from here I will select all the columns which I have defined, add here, modify, start definitely from column 300 by 300. I forgot to define the modifiers. For example, I have defined in all the columns in the beams and column members. For example, in beam 225 by 225, I didn't define the property modifier. So here I will put 0.35 moment of inertia. Why? Because in the ACI building code requirements for structural concrete and commentary, ACI 318M14, moment of inertia and cross-section members permitted for elastic analysis should be moment of inertia 0.7 Ig for columns, and for beams 0.35 Ig, and for slabs 0.25 Ig. Because in the concrete members we consider the crack cross-section members, because we do not consider the concrete area which is in the tension side. So that's why the code refer that use the moment of inertia, cracked moment of inertia like these 0.7, 0.35 and 0.25. 0.35 for beams and 0.7 for columns. So that's why I have changed the moment of inertia 0.35. Okay, and I have not defined also in the column 300 by 300 modify property. Here I will put 0.7, and in the two direction also, because in columns both moments are usually present, mx and my, so that's why I define in both directions. Okay, you can also check in all the beams I have defined that property modifiers in the beam 0.35, and in the column, any column, you can check that I have defined the property modifiers. Okay, so after that, defining the beam material and cross section material, there is one last thing we have to define: the slab section. Here is already two slab section have defined. I will define a new add property. Slab material, I also select 28 megapascal, slab size of 175 mm, and I am putting here 175. There are different types of slabs: drop, draped, and waffle slabs. We will select simple slab and hit OK. So here I have also defined the slab property. Now after defining the slab material, slab cross section, column cross section, beam cross section, now I will go towards the drawing of the members in the grid system. I will go in the plan, in the story to apply. Okay, from here I can select draw beams and column, and here is the option quick draw beams. I will select quick draw option, quick. So here I will select the auto select beam, because auto select beams all beams are present. Software automatically optimize the cross section here, and definitely check that it's a one story. So I am going back. I will select all stories and then draw. What will happen? You can see I will drawing in the story 2. Automatically in the story 1 there is a drawing of the beams happening. So I will again go back to story 2 plan. Okay, here. So in the center of the hall there should not be any beams or columns, so that's why I will just select one story and then draw beams. Okay, now I will draw the, now you can check that I have defined the beam members. Now I will define the column members at the perimeter only, because no column is allowed in the center of the hall. So now I will select auto selection column. So here from this option, sorry, I will select auto selection column, and here I will draw one by one column, not only in one story, in all story. I will do undo, and after that I will select one story. When I click on this, automatically all column will draw in the lower story also. plan, apply, okay. So I will define the columns only at the perimeter. Here. After that, only slabs are required. So I will click quick draw slabs. So I will select the property which I have defined, slab 175 millimeter. On not in all stories, only in the one story. Here, 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 here. So it's a very quick process. So now we can check we have successfully modeled our uh, TV studio. So I will change the boundary conditions to make the spots fixed. Plan, base, apply, okay. So here you can check the spots. I will select all the spots. After selecting all the spots, I will go to assign joint restraints, select fixed spot, apply, okay. Now you can see the all spots at the under the columns are in the fixed condition. Now I will define the loading in the panels, apply, okay. After selecting the panels, all the panels, I will go to assign shell loads, uniform load. Basically it's in kilonewton per meter square units. I would like to apply the load in kg meter, okay. Again I am going back towards the uniform loading. Here you can see kg per meter square. Now I will define 50 as a super dead load, apply. Again select get previous selection, which is I have a little time before selected. So now I will apply live load, apply, okay. So you can check in each slab both loads are present by right clicking on any member on any panel. So in the loads you can see there is a dead uniform load 50 kg per meter square and live load of 300 kg per meter square, okay. Define in load patterns, we can see there is a two load defined dead and live, and there is a dead weight dead self weight multiplier 1. It means software automatically calculate the self weight of the members of slabs, columns and beams, etc. So that's why here is a one option. So dead and live loads, okay. So now I go towards the load combination. So there is two combinations, dead and live, 1.2 dead, 1.1 live. There is already defined. I will delete and define again, add new load combination, 1.4 dead. So here is dead, I will just multiply with 1.4, okay. Now I define another load, another combination, 1.2 dead plus 1.6 live. Here I will define the multipliers, 1.2 and live 1.6, okay. Now I have also defined the load combination successfully. Now after defining all the things, I will save the model. After saving the model, I will run analysis. Before running analysis, you must check your model that is the model successfully correctly model. So I will go towards select all, okay. If there is any overlap of the members, any issue, here warning messages will appear. So no warning messages were generated, so that's a good thing. Our model is successfully generated. So here in 3D you can check. Now after applying the dead loads, each and everything, now I will go towards the analyze. So here is run analysis. After running analysis, we can it automatically display the displacements against dead in meter. So I will just change the unit system into metric SI. So here you can check, here is the deformation, much more deformations. So let's check the shear force and bending moments in the frame. In the normal gravity loads, we will for the moment we click on the moment 33, apply. Here we can check in each member the moment, what are the moments, and for the shear we click shear to apply. So here we can check that in each member what is the shear. Okay, so all things, we can also check the details forces by right clicking on any member. Here I right click the, here I can see the shear force at any location. For example, the total length of the member is 7.5 meter, so I can check the shear, moment and deflection, etc. Done. So now I go towards the designing, concrete frame design, view, revise or preferences, etc. Here are the preferences. We are designing the concrete members according to ACI 31814, and there are also other conditions like what will be the factor for the tension control, compression control, and etc, etc. Okay, and now I will go towards select design combinations. So definitely two design combinations we will select. So after this we go towards the start design check. It will take some times because we have selected the auto beam selection. It will optimize that, um, which beam section is suitable. So it will perform many trials. So after performing many trials, it will show that which members are suitable for our design purpose. Here, analysis and design section different for 8 group members. Do you want to reiterate analysis and design? Yes. Because the design member is different from the analysis member. So software is trying to confirm that the analysis section should match with the design section. So that's why the software performing the design analysis again and again. So now the 4 members are remaining only. Again, here in the plan. Okay, we can see the members are showing the longitudinal reinforcement. For example, we click that member, and here we can see the bottom steel, the top steel, and the shear steel, etc. I am hitting OK. We can check what is the shear reinforcement. Here is design shear, design moment. So in this summary we can check all the details like what is the story level, what is the beam element ID. Here it's a beam 450 by 750. The software automatically optimize these sections. So here we can see the shear is 24 and the shear capacity is 204. Definitely it's much larger than the applied shear. So here is a torsion, so no reinforcement is required.